We're now going to talk about standard enthalpies of formation. The standard enthalpy of formation, delta HF, is defined as the heat change that results when 1 mole of a compound is formed from its constituent elements in their standard states. We're going to be using this standard enthalpy of formation going forward, so it's important that you know what it means. So let's take an example. Carbon, and one of its allotropic forms is graphite, plus molecular oxygen O2 goes to make carbon dioxide as a gas. And its standard heat of formation is delta HF superscript 0 is equal to minus 393.5 kilojoules per mole. So going back to the definition, is heat change results when you make a mole of the compound, so we're making a mole of CO2 from its constituent elements in their standard states. Carbon, graphite form, plus molecular oxygen. The superscript degree sign denotes standard conditions. What are the standard conditions? It's going to be 1 atmosphere pressure for gases. We're doing this reaction at 25 degrees Celsius. If there happen to be solutions, the concentration of those solutions will be 1 molar. So that superscript 0 means 1 atmosphere pressure for gases at 25 degrees C, 1 molar concentration for solutions. The subscript F stands for formation. We're talking about the standard enthalpy of formation. And one important thing to note is that the standard heat of formation for any element in its most stable form is 0. This delta HF 0, superscript 0, is for any element is equal to 0. And we'll be measuring these. The units will wind up being kilojoules per mole. And we can find many delta HF superscript 0s for all sorts of different substances and tables. Appendices in the back of the books, tables in the middle of a book chapter. And these aren't things that you need to memorize. They'll always be supplied for you. But remember, elements in their standard state, that's most stable form, that delta HF 0 is 0. So let's take this generic equation of a reaction of A moles of A plus B moles of B react to make C moles of C plus D moles of D. The capital letters refer to some different chemical substances, and the lowercase letters are the stoichiometric coefficients. So A moles of A plus B moles of B react to make C moles of C plus D moles of D. This will be a famous or very much used generic equation throughout your career in chemistry. So the delta H0, the change in enthalpy for a reaction, that's what that subscript RXN means, is going to equal the sum of the delta HFs for the products minus reactants. Products minus reactants. Remember, we're talking about a state function. That's what enthalpies are. That's what delta H is. Whenever we're measuring a change, it's always final minus initial. So when we're talking about a chemical reaction, it's products minus reactants. So we'll have C and D are the products, and A and B are the reactants. So what this delta H0 for the reaction is C, the stoichiometric coefficient for compound C, times its heat of formation, plus D, the number of moles in the balanced chemical equation, times the heat of formation of D. Add those up, that gives you the sum of the heats of formation for the products, and then we'll subtract the heats of formation for the reactants. So A moles tells us to multiply the heat of formation of A times the stoichiometric coefficient for A, plus B moles times delta H0 of formation for compound B. And so we can summarize this in this equation, that, and I've sort of verbally said it earlier, that the change of the heat of reaction, the enthalpy of reaction rather, is equal to products minus the reactants. So the sum of N times the heat of formation for the products minus the sum of M times the heat of formation for the reactants, where N and M are the stoichiometric coefficients for each of the reactants and products.